Hey guys, this is Anna and I'm going to demonstrate on how to do my red cabbage indicator experiment. Safety is really important in any experiment, so my safety of choice is an apron. These are the supplies and equipment we're going to use. So we're going to start mixing our first chemical solution, which is baking soda and water. Baking soda is an alkaline. This means that there's less hydrogen ions in this solution than any acidic solution. So what I'm adding here is 1 teaspoon of baking soda to 1 cup of water. This mixture is a homogeneous mixture because of its uniform composition, which means it's all mixed. So for our next solution, this is soapy water. Once again, this is the base. The soap in this water is soluble, but not all types of soaps are. But what I'm doing right now is just adding a few drops of soap to the water. Our next chemical is water, so we just have to pour 1 cup of water to the plastic cup. For our next solution is cream of tartar and water. The solution of cream of tartar is more acidic than water. This means that it has more hydrogen ions than water. This is an ionic compound as well as the others except for water because water is a molecular compound. Our next solution is 1 cup of water and alka-seltzer, but we're going to add the alka-seltzer later. Alka-seltzer is a really strong acid because it contains baking soda and lemon that creates the fizz. Our next chemical solution is lemon. I added 1 cup of lemon to the cup. Lemon is really acidic. Lemon has one of the highest acidity levels on the pH chart. For the last chemical I'll be using is vinegar. Vinegar is very acidic as well as lemon juice. Vinegar's acidity level is at 2.7 as well as lemon juice's. Alright, so we have our red cabbage and we're just gonna take off 2 leaves and put them in the blender and add water. After the blending, we are filtering our solution. The separation method I'm using is filtration. The filtration method separates any solid from our solution, and we are using a coffee filter and a strainer. This is the most useful way to filter out your red cabbage solution. The red cabbage solution acts as an indicator. Red cabbage contains a pigment called anthocyanin. Anthocyanin is a pigment that is found in many plants. This pigment changes color when it's mixed with any acid or base. We're adding the cabbage solution to the baking soda solution. The solution turned into a bluish greenish color. As we know, the baking soda solution is a base. A base is an aqueous solution that gives away electrons, accepts protons, and releases hydroxide. This solution is soapy water. As we can see, the soapy solution is more purple than the baking soda solution. Our next solution we can see here is water, and it's darker than the other 2 solutions. Water is neutral. It's neither a base or an acid. This is why water does not affect us. Our next solution is a cream of tartar solution. Cream of tartar is more on the acid side. Our next solution is going to be the alka-seltzer solution. Alka-seltzer is an acid. An acid is a chemical that gives away hydrogen ions and protons and accepts electrons. The fizz comes from the chemical reaction of citric acid and sodium bicarbonate that is in the tablet when you drop it in the water. The alka-seltzer tablets are less acidic than the cream of tartar solution. This means that the solution is more neutral than the cream of tartar solution. The solution we have here is lemon juice. Lemon juice is very acidic. As you can see, it turned into a really pink color. The different colors we see depends on the different molecules the object is made of. Light contains every single color of the rainbow. Each different color you see has a different wavelength. Different types of molecules absorb different types of wavelengths. The wavelength that reflects off the molecule we see with our eyes determines the colors we see. The rest of the colors are absorbed. For example, when we added the indicator to the vinegar, the indicator is flooded with hydrogen molecules and causes the indicator to change shape and change into a really bright red color. Another example would be if we added indicator to the soapy water. This means that there's a high amount of hydroxide molecules causing the shape of the indicator to change color and to reflect a blue color. This indicator is irreversible, so that means that you could add acids and bases and it will change colors back and forth. Well, I hope you guys enjoy my red cabbage indicator demo, and I hope you guys